This is Advanced Math, Lesson 11.6. The title is Hyperbolas, and we're going to start with standard form. Okay. Standard form for hyperbolas is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. All right, does this look very similar to our does it look very similar to our ellipse standard form? I'm going to show you really quick. There's standard form for an ellipse. Does it look very similar? Yes? Okay. It should look very similar. What's the only difference? The minus sign. All right. Let's go back to the ellipse. Is addition commutative? Like 3 plus 5 equals 5 plus 3. Does the order matter? Oh, it doesn't matter. So addition is commutative. Yes. You're saying yes? Okay. It is commutative. Is subtraction commutative? Is 5 minus 3 the same as 3 minus 5? No. Okay. So on this one, if I had flip-flopped the x and the y variables, like if I had put the y quantity squared before the x quantity squared piece, would it have changed the graph? No, because the addition is commutative. On this one, if I flip-flopped them, will it change the graph? It will, because subtraction is not commutative. So we are going to have two different graphs, kind of like we did with the parabolas, where there was an up or down and then there was a right or left. So let me show you what the first one looks like. Okay, when it looks like this, I'm just going to center it at the origin, and we're going to have asymptotes, 2 of them. Now our asymptotes will always both intersect at the, not at the origin, but they will always both cross at the center, wherever the center's at. This one is going to look something like this. They both approach the vertices. They kind of look like parabolas going in opposite directions. And like the parabolas, they have two foci, and the foci are like the sugar cubes always inside the cups. Got it? Okay, so that's the vertex, that's the focus, or those are the vertices, those are the foci. We do have the focal length. The distance from your vertex to the star is your focal length. We will talk about that in just a bit. Now, with the ellipse, I did not give you guys any formulas. If you remember, with the parabola, I gave you guys formulas, and some of you used them and some of you did not. With the ellipse, I gave you no formulas. We just did everything visually. With this one here, I am going to give you formulas, but like the parabolas, I'm going to show you both ways. Okay, so here are the how many of you guys don't use the formulas and do it visually anyway? Okay, so I'm going to show it that way because I've said it before, I don't use formulas, I just do it visually because I don't want to put any more things in my head if I don't have to. Okay, and there's a lot of formulas to memorize anyway. Okay, so here they are. They are, the center is h comma k, and I will let you know which ones are necessary whether you're visual or not. The center is h comma k. And we all are going to use that, whether you're a visual person or a formula person. So I'm going to put a star by that one. And the vertices are h plus or minus a comma k. Foci are h plus or minus c comma k. The h, the k are coming from the center. The a is coming from the square root of the a squared. The c is coming from the focal length formula, which I haven't given you yet. And then this last piece here is the equation of the asymptotes. Y minus k, coming from the center, equals plus or minus b over a, coming from the b and the a, parentheses x minus h. If you didn't notice it, this is the point slope form for the equation of the line. It's usually y minus y1 equals m times x minus x1. Y minus y1, y value of the center, equals the plus or minus the slope, x minus x1, the x value of the center. Why the center? Because both lines, both asymptotes cross through the center. So that's the point we're always going to use. The m, the slope, is rise over run, b over a. We'll talk a little more about that in just a little bit. Okay, and this formula here, both of us, all of us will always use, regardless if we're visual people or formula people. All right, questions? Okay. Now, the other format, if y comes first instead of x, is going to look like this: y minus k quantity squared minus x minus h quantity squared equals 1. And I did forget to write the fraction piece. This first one's over b squared. The second one's over a squared. Now this graph looks like this. I'm also going to center this one at the origin. They're not always at the origin. This one also has asymptotes. And the difference is this one opens up and down. And the graphs approach the asymptotes. Okay, and like the other one, the foci are inside the teacups. All right. Okay, so I'm going to write the formulas. The center is h comma k, and that is what we're all going to use. And notice it's the same as the center here. Now it's going to be different, a little different. Be careful. The h is coming second and the k is coming first. We're over here, h is first and k is second. So be careful. That does confuse kids sometimes. Just make notice that h is hanging out with x and it goes in the x spot. K is hanging out with y and it goes in the y spot. So x with x, y with y. All right, the vertex is h comma k plus or minus b, coming from the b spot. Foci is h comma k plus or minus c, c coming from the focal length, which I haven't given you that formula yet. And then our formula for the asymptotes is y minus k plus or minus, or equals plus or minus b over a parentheses x minus h. And this is one as well that we're going to all use. So I'm going to star that one and bubble these in. Okay, now notice the two formulas that we're all going to use are exactly the same regardless of which form we're using, and that's nice. Y minus k equals plus or minus b over a times x minus h. All right, focal length formula, and then we'll talk about the difference between the two. Focal length is c squared equals a squared plus b squared. What formula is that? Does that look like a familiar formula? What is it? Is it Pythagorean's theorem? Do you guys agree? Yes? All right. It looks very it is, but it also looks very similar to our ellipse focal length formula. This one's the one we had for our ellipse. Why does this one have an absolute value and this one does not? Anyone know? Yes.
Because this one's already addition.
This one's an addition. Here, I'm subtracting two negative numbers, which there's a possibility it could come out negative. Here I'm adding two positive. I'm going to repeat that. I'm subtracting two positive numbers. I don't know if I said that properly. I'm subtracting two positive numbers, which means there's a possibility it could come out negative. Here I'm adding two positives. It's never going to come out negative. Do you guys get that? Okay, so I don't need absolute values. Got it? Any questions on the focal length formula? Okay, some kids always get confused. Which one's which? Is it plus? Is it minus? Here's one trick to remember it. If you're dealing with an ellipse has a plus sign in their standard form, which means the focal length has a minus. It's the opposite. Plus here, minus here. The hyperbola has a minus sign in their standard form, so the focal length formula has a plus sign. It's the opposite. Minus here, plus there. Any questions? Okay, so before we get to the last piece at the bottom, how do you know what goes where, blah, blah, blah. Notice nowhere did I talk about the major axis like we did with the ellipse. The ellipse, we talked about the major axis and everything runs on the major axis. Is that the case with hyperbola? Not at all. Hyperbolas have nothing to do with the major axis. We don't talk about it, we don't mention it at all. We talk about a transverse axis and a conjugate axis, but nothing to do with the major axis. Okay, so what determines which direction it opens, or where the foci are, where the vertices are? What determines all of that is what variable comes first. What determines everything? The variable that comes first. Okay, so if x comes first, you think, which direction does the x-axis run? Up and down or right and left? Right and left, so your hyperbola opens right and left. And if your hyperbola opens right and left, then everything runs right and left. Your vertices are right and left, and your foci are right and left. Does it matter if it's the major axis or the minor axis? Everything is right and left. If your y variable comes first, you think about which direction does the y-axis run? Right and left or up and down? Up and down. Therefore, everything's going to be up and down. Your graph is going to be up and down, which means your vertices will be up and down, and your foci is going to be up and down. It does not matter where your major axis is. Everything's going to be up and down. Any questions? We're good? Okay. All right. Last piece we're going to talk about before we do examples is the transverse and conjugate axis that I mentioned earlier. Okay. Length of the transverse axis. The length of the transverse axis is the distance between the vertices. So the transverse axis is kind of like what used to be the major axis, right? The distance between the vertices for our ellipses was the major axis. It's not necessarily going to be the major axis here because it could be the smaller one, but it's the distance between the vertices. Whether it's the major or the minor does not matter. It's the distance between the vertices. Next one is the length of the conjugate axis. And this is the distance between the points that are not the vertices. Now, I don't think I told you guys the last time I saw you what those points are called. The points that are the non-vertice points are called co-vertices. Co-vertices. So I'm going to put that back up, but I'm going to cover it really quick. So for an example, with an ellipse, those would be the vertices. Those would be the co-vertices. Vertices, co-vertices. Okay. Questions on anything we've covered so far? Okay. As I've stated before, a lot of formulas and a lot of graphing. How many of you feel like I've got it, I can memorize all these formulas before the test? Anybody? How many of you feel like, nah, I don't want formulas, just give me the pictures and the image and I can work with it that way? Okay. I'm going to continue. Before I do, anybody need this page up a little bit longer? How many of you feel like I can use the formulas on the homework, but I'm going to do it image-wise on the test? Yeah? Okay. All right. I am going to continue. Number 1, sketch. Y minus 3 quantity squared over 4 minus x plus 1 quantity squared over 36 equals 1. Okay. We are going to get through this. Center, V for vertices, F for foci, TRANS for the transverse, the length of the transverse axis, CONJ for the length of the conjugate axis, and a blank line for the equation of the asymptotes. Okay, I am going to show you how the size of your graph, your axes that you should have. All right, so the center, we all use the same formula, h comma k, opposite of the inside for both of them. And remember, it's not always first spot, second spot like it was with the ellipse. Keep in mind, if you mess up on the center, everything else is wrong. Your picture's wrong and all of this is wrong. Please do not do that to yourself. And it happens on the test where there's one like this, where if you mess up on the center, everything else is wrong. What's the most common mistake kids make on this one? This. Did anybody do that by accident? It's okay if you did. Anybody do it? Maybe? Okay, remember x goes with x, y goes with y. So what goes in the x spot? -1, because that's with the x. What goes with the y? 3. Go left 1, up 3. Okay, right and left, whatever's underneath the x. So right and left, how far? 6. 1, 2, 3, 4, 5, 6. Left 1, 2, 3, 4, 5, 6. Up and down, whatever's underneath the y. So how far up and down? 2. 1, 2. 1, 2. Now, you do pretty similar at the beginning like you would an ellipse. Right and left, up and down. After that, do not make an ellipse. What you're going to do is make a box shape, a dotted rectangle like this. This is going to help you with your asymptotes. These are not your asymptotes. This box shape is going to help you to draw your asymptotes in a little bit. Okay, everybody have their box shape? Here's how you draw your asymptotes. They're your diagonals for this rectangle. You go through your center, through your corners, like that, diagonals. Remember what I said, that both the asymptotes will always intersect at your center? That's why we use our center for our equation of the asymptotes here for our point. Okay, any questions so far? All right, which direction are we going to open? Right and left? Because those are the 2 points that are furthest apart. Is that how I figure it out? Yes or no? No, I do not care which 2 points are furthest apart. I look at what letter comes first. What letter comes first? And which way does the y-axis run? So which way are my graphs going to open? Up and down. So do you guys see how the asymptotes help guide us on how wide or narrow? If my hyperbola was opening right and left, it would be more narrow, versus up and down is going to be more wide. Do you see that? Because my hyperbola goes towards the asymptote, it's going to be pretty wide. If it was opening, I use those points that I went up and down. If it was opening right and left, it would be pretty narrow. Okay, so I used the points when I went up and down, these points right here, versus these when I went right and left. Those are the 2 points right there, the co-vertices. If I was going right and left, I would be pretty narrow. Okay, so I'm just gonna put those in color. Okay, so I'm gonna repeat what I said. Do you guys see where the size of your rectangle determines how wide or narrow your hyperbola is going to be? Yes? Okay, so use your formulas or look at your picture. Find these vertices here. You went left 1, up 3, and then from there you went up 2 and down 2. They're pretty easy to find. They'll be even easier when you have graph paper on the quiz and the test, or if you have graph paper on your own when you're doing these. What are they? -1, comma, and -1, comma. Did anybody use the formulas and get the same answer? Yep. Okay. Foci, we're going to use our formula. I'll do it up here. C squared equals A squared plus B squared. So 36 plus 4. C equals the square root of 40. Do you guys know how to break that down? 4 times 10. Take the square root of 4. What's the square root of 4? So 10 is not a perfect square, and it doesn't break down into any perfect squares. So what does C equal? 2 root 10. All right, now how you figure out how long the square root of 40 is up to you. You do not need a calculator. You can use it, but you do not need it. What 2 perfect squares is 40 in between? 36 and 49. What 2 integers is the square root of 36 and 36 of 49 between? 6 and 7. So that means the square root of 40 is somewhere in between 6 and 7. Now, if you don't want to do that work in your head, that's not too hard. You could just plug it in. 40 square root is 6.3. You can't see it. And is that what we came up with when we did it in our head? Yes? Okay, so which direction do I go? Up and down or right and left? Right and left because it's longer, or up and down because y is coming first? Up and down, because that's the way my graph is opening. So up and down about 6.3. 1, 2, 3, 4, 5, 6.3. 1, 2, 3, 4, 5, 6.3. All right, any questions? Now, if you're doing it visually, which is the way I prefer, you're going to do it the same way we did with the ellipse. From the center, because everything is from the center. When you're moving up and down, which value is changing? Your x value or your y value? The y value of your center. So is that the -1 or the 3? When you're going up and down, what's changing? The -1 or the 3? The 3. So you leave your -1 the same, and then 3 plus or minus 2 root 10. And that's how you leave it. Those are 2 ordered pairs. -1, comma 3 plus 2 root 10. -1, comma 3 minus 2 root 10. We just write it like that. Okay, these 2 are pretty easy. Transverse is between your vertices, and my vertices are not the 2 points furthest apart. It's these 2 here. I went up and down 2. What's the length here? What's the length here? 4. Conjugate, or the co-vertices, what's my length here if I went right and left? 6. 12. Okay. Any questions? All right, equation for my asymptotes. I'm just going to put a little arrow here just to let you know. The formula I'm using here is technically this one. Have we used this formula before? Point slope form. Have we seen that formula before? Lucas, yes. Have we seen this point slope form before? Yes? All of you guys, have we seen this before? Yes. Y minus y1 equals plus or minus the slope, x minus x1. Now, for the x1 and y1 point that we use the center. Why the center? Because both lines have the same point at the center, right? The slope, I use b over a. Why b over a for the slope? Because from this point to that corner, I rise 2 and I run 6, which happens to be b over a. Will it always be b over a? Yes, it will. I will always rise the b value and run the a value. Does that make sense? You need to know that, by the way, because that comes up as a test question. Plus or minus b over a, I'm going to do that right now. What's b? What's b? 2. What's a? What does that reduce to? 1/3. All right, let's plug it in over here. According to the formula that I gave you guys earlier, instead of y1, we're going to use k. Instead of x1, we're going to use h, and that's just coming from our hk. So y minus the y value of the center, which is 3, equals plus or minus b over a, which we got what? 1/3, and that's plus or minus because it's a positive slope and a negative slope. There's 2 asymptotes. And then x minus the x value of our center, because both of them cross at the center. What's the x minus -1 would be what? +1. And those are all of my answers. Any questions? Did anybody do it all visually and no formulas? Did anybody do it all formulas? Same answers? Okay, any questions? All right, number 2. X minus 1 quantity squared over 16 minus y plus 2 quantity squared over 9 equals 1. Before we even start, can you guys tell which direction this opens? Why is it left and right? Because x value comes first, yes? Now, if you're taking a test and you see this, and would you know it's an ellipse or a hyperbola? Because of the minus, it's an hyperbola, not an ellipse. Yes? Okay. Center, vertices, foci, length of the transverse axis, length of the conjugate axis, and the equation of the asymptotes. Okay, for your center, it's opposite of the insides. X goes with the x, y goes with the y. So 1 comma -2 or -2 comma 1. Be careful. Which one is it this time? 1 comma 2? Yes, 1 comma 2. All right. So go right up 2. Right 1 up 2. And whatever's underneath the X. Yes. Oh, thank you. I looked at my graph and I was like, wait, I went down, and that's because I wrote this row. 1, -2. Thank you. That did scare me for a quick second. My graph looked off. Okay, 1 down 2. Okay, everyone agree that it should have been 1 down 2. Yes, 1 -2. Okay, everybody fixed it? 1 -2. Okay, again, underneath the X is the right left. Earlier it came second, but now it comes first. How far right and left? How far right and left? 4. 1, 2, 3, 4. 1, 2, 3, 4. And how far up and down? 3. 1, 2, 3. 1, 2, 3. Dot, 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 all the way through. Okay, and then make your diagonals that are acting as your asymptotes. And then you guys already said it's opening up and down, which means everything is running up and down. Your vertices, your graph, your vertices, your foci. Right and left, that's what we said. My apologies. Ooh, did I mess up? Which piece? 1, 2, 3, 4. 1, 2, 3, 4. That piece? Thank you. Okay. Hopefully you guys did not. And go ahead and sketch. Which way did you guys say it was opening? Anybody, which way did you guys say it was opening? Up and down or right and left? Right and left. So go ahead and do that now. Lucas, thank you for catching that. Okay, everything good now? 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay. Did you guys graph it already for your right and left? If it's opening right and left, which way are the vertices running? Right and left or up and down? Anybody? What? Right and left? So go ahead and find your vertices now. These points right here are your vertices, the ones that I just darkened in. Now, are they your vertices because they are the points furthest apart, or because your graph is running right and left? Because the graph is running right and left. Okay, so what are they? Anybody have them? 5, -2, and -3, -2. Everybody agree? Okay, I'll do the foci after. Transverse axis, what's the length? Right and left, how far? 8. Up and down, how far? 6. Here I have y minus -2, which would be +2 equals plus or minus 3 over 4x minus 1. All right, any questions so far? What did you guys get for c² equals 16 plus 9. What did you get? Square root of 25. What did you get for C? All right, did it come out to be a square root value? Did you get a square root value or a whole integer? So do you have to write it as that crazy plus or minus thing? No, you're actually going to get two ordered pairs. So what I would do if I were you, you could use your formula, but I would just come here and go 1, 2, 3, 4, 5, put an ordered pair. 1, 2, 3, 4, 1, 2, 3, 4, 5, put an ordered pair, or a dot, sorry, and write that ordered pair. If you're visual, you're not using the formula, you're just going there and figuring out those two ordered pairs. If you are using the formula and you're plugging it in, you're still going to write it as two separate ordered pairs. If you're using the formula, plug it in, the plus or minus 5, and get two separate ordered pairs. If you're not using the formula, then you're looking at your graph. What are they? 6, negative 2, and did any of you guys use your formulas? Did you get those? Did anybody just use your graph and your eyeballs? Did you get the same points? Any questions? Make sense?